Hey everybody, Sakani here. Today I have a very interesting problem. Prove the functions y squared equals 4x and x squared equals 4y. Divide the area of the square bounded by x equals 0, y equals 0, x equals 4, y equals 4 into 3 equal parts. And at first this problem may seem a bit intimidating, but as I like to say, always draw the graph first and then it makes much more sense. So I'm going to draw it right now. I'm going to start off with our axes. And I'm going to draw this function first because I know that x squared equals 4y is just y equals x squared over 4. And that looks something like this. So this is y squared equals, or excuse me, x squared is equal to 4y. And now let's draw this graph right over here. I know this is going to be a sideways parabola. It's going to be opening up something like that. All right, that is y squared is equal to 4x. And now we have to draw this square bounded by these 4 lines, okay? So we have x is equal to 0. Well, that is just this part over here, right there. And then we have y is equal to 0. So that is this whole line over here. Whoops. This whole line over there. So I'm just making a mental note of that. And then x is equal to 4. And interestingly enough, x is equal to 4 lies right here. It's the x coordinate of that intersection point. And how do I know that? Well, it's just some basic algebra that I could do on the side. If we're trying to find this intersection point between the two graphs, let's set the y values equal to each other. So from here, I know that y squared is equal to 4x, and hence y is equal to 2 root x. I know there should be a plus or minus, but I'm just concerned about this part, which is going to be that positive 2 root x. And this part is just going to be that negative 2 root x. But I'm only concerned about the positive part, so I'm just going to take the positive value of that. So we have y is equal to 2 root x. From over here, I know that y, we said, was equal to x squared over 4. Next, we have to set these y values equal to each other. So we have 2 root x is equal to x squared over 4. Let's multiply both sides by 4. So 8 root x is equal to x squared. I'm going to square both sides to get rid of that root x. So we have 64x is equal to x to the power 4. I'm going to take this to the other side, so 64. X is equal to 0. I'm going to take an x out. X cubed minus 64 is equal to 0. From here, we know that x equals to 0 is definitely a point where they intersect, and we could see it right over there. But what do we do for this one? Well, we apply the difference of cubes. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So I'm just going to apply that right here. And from here, we see that we get more roots, and we don't really care about this root because as of now, we have found out the points that they definitely intersect is 0 and 4. So that is how I know that it intersects right over here. Correspondingly, we can find the y value by putting it in one of the functions. So the corresponding y value is also going to be 4. All right, so enough of that. Now we have x is equal to 0, y is equal to 0 done. X is equal to 4 is this part right over here. That is x is equal to 4. And y is equal to 4 is this part right over here. So the square they're talking about is this square right over here. And they're saying we have to prove that these two curves divide this square into 3 equal parts. So part 1, part 2, part 3, we need to prove that the areas of those are equal to each other. So we have to find the area of each individual part and see if they're equal to each other. I'm going to label this as A1, and I'm going to label this as A2, and finally, this part is going to be A3. So let's take it step by step in solving the areas. So I'm going to solve for A1 first. Now, in order to solve for A1, we could do it 2 ways. We could either take the vertical strips or we could take the horizontal strips. And just to prove that they get the same exact area, I'm going to do both, but just for this A1 area. So let's say we want to find the area using vertical strips, right? So we're going to use vertical strips. I know that this part, the horizontal part, is going to be dx. That's the part that has to be really, really small. This part is going to be this 4. I'm going to write that over here. This part is going to be that 4 minus this function over here. And that function, we need the y value of that function. And the y value of that function is 2 root x. So 4 minus 2 root x. Because we're just concerned about the y values. So we're doing essentially this whole thing minus this whole thing, which is going to give us this whole thing. I hope that's clear. So I know that the whole thing is 4, right? And I know that this thing is y. And from here, we just solve for y, which was that 2 root x. And I'm just going to subtract them to get the y value of that pink part. So let me just go back. Now we can start solving for a. So I'm going to, start solving for a1. So I'm going to have a1 integration, and this is going to go from left to right. So this part right over there. So 0 to 4. 4 can be written better, 4. And now we're going to have our function, which is this part right over here. So 4 minus 2 root x dx. Now we can just simplify this. So 4x minus 4 thirds x to the power of 2, x to the power of 3 halves, 0 to 4. Then we have 4x minus 4 thirds. I'm going to rewrite this as this so it's a bit simpler. I'm going to say 0 to 4. Substituting that 4, we're left with 4 times 4, which is 16, minus 4 thirds times 4, and then root of 4, which is just 2. And then just 0, because if we substitute 0, everything becomes 0. Solving this, we get 16 minus, 32 thirds. Common denominator, 48 thirds minus 32 thirds. That is equal to 16 thirds. So that is our area for A1. That's how we solved it with the vertical strips. Now let's try solving it with the horizontal strip. All right, so let's start by solving it with the horizontal strip. So now we have horizontal over here. This is going to be dy, and we need x. Now solving it with the horizontal strips is much, much easier than solving it with the vertical strips. And what I mean by that is this. So we have x over here, right? And that is of this curve over here. And this curve is this curve right there. And we know x is equal to y squared over 4. So I could say a1 is equal to, and we have to know our bounds, of course. So our bounds are going to be here all the way to that 4. So 0 to 4. And our function is just going to be that y squared over 4. And then, of course, dy. And you can see that's much easier than doing that 4 minus 2 root x. But either way, you get the same answer, because if I try simplifying this, I'm going to take that 1/4 out, because it's a constant, y squared dy. 1/4, 1/3 y cubed, 0 to 4. I'm going to take the 1/3 out, y cubed over 0 to 4. And that is 4 cubed is what, 64 over 12. And then we can divide that by 4. So bottom is 3, top is 16. And that is exactly the answer we had previously. So over here, it's easier to solve with horizontal strips than vertical strips. But either way, you get the same answer. Now, let's start solving for A3, because A2 is a little bit trickier and I want to get to that part last. Let's just solve A3. So now let's solve A3. And in this case, the vertical strips are going to be easier. So I'm going to take the vertical strip, and this is going to be dx, and this is going to be y. Now the reason vertical strips are easier in this case is because this function is already defined in terms of y, right? We know that from here, y is equal to x squared over 4. So our integral would just be A3 integration, and we're going horizontally. So this to over here, so 0 to 4, 0 to 4 of y, which we said was x squared over 4 dx. And this is much easier because if we use the horizontal strips, then we would have to do 4 minus something else, and that would be more confusing. But for right now, we're just going to use the vertical strips for A3. And solving this, we also get 16/3. So we know that A3 is also 16/3. Now we just have to solve for A2. Now solving for A2, it doesn't really matter if you take vertical or horizontal strips. They're just going to be equally as difficult or easy to solve. So I'm actually just going to take vertical strips. So if you take vertical strips, we know that this is dx and this is y. So we need to find y. So in order to find y over here, it has to be this minus this, and that would give us y over here. So in order to find this part, we know that the curve is y squared is equal to 4x, and we know that from here, y is equal to 2 root x. So I'm going to have A3 is equal to integration. Let's do our bounds first. So we are going horizontal once again, so 0 to 4. And it's always the top function minus the bottom function. So top function we said was 2 root x minus the bottom function, which is this part right over here. And that we said is this, x squared is equal to 4y. But once again, we need everything in terms of y, like y equals whatever. So in that case, y is equal to x squared over 4 dx. And from here, we can start solving it. And we are left with 16/3 once again. So since all of them have the same area, we have proved this statement.